The reason why Jacobian matrix was one of the last things I learned, in math, is because the proof, I looked online, I looked everywhere, and it doesn't have a proof that I like. It always has some kind of intuitive aspects of it. And to be fair, I have not watched a YouTube video. Probably would clear everything up, or maybe I should just look at another textbook. But I read like two textbooks already on Jacobian, and then it was not useful. And then I looked at a few other stuff, and it really wasn't useful. So online, so I think I need to go a little deeper. Probably need to find actual a textbook that's dedicated to Jacobian, maybe. That's gonna be pain. That's gonna be painful to actually understand the Jacobian proof later on. I really want to know that. But I also do know that there's a proof. I know the intuitive proof. I know the intuitive proof. But I'm not putting it in here until I understand the actual, real, non-intuitive proof that everyone keeps on shoving up my ass to my math when I was in the math when I was learning in the math department, which is some kind of like parallelogram, and this parallelogram go over here in the R region that you transform to here. It's kind of like the Laplace transformation, Z transformation, Fourier transformation. Although Fourier I learned in the math in the MAE department, not in the math department, weirdly enough. Um, so, anyways, um, on to the next point is that it can. Oh, yeah, I didn't even describe what the Jacobian does. It creates what was it again? It allows an integral to be a box or a rectangle. What does that even mean? It means that if you have a weird ass like boundary conditions, you can change the boundaries to be a box. You can slant it over into a box, making it A, B, C, D, or in the case triple integrals, you can finally justify a little bit of triple integrals. You can already justify it for density later on in physics, which is why I didn't put it here. It's in the physics section. But basically what it does is allows us to do the boundary where we did the the weird boundary with the defining the it's in here anyways, defining this thing like this. We can transform it into A, B, C, D, and get rid of the meat, the middle, um, like lines everywhere and doing all these confusing shit. It'll still be more confusing, but there's a system for it. Let's just say that. Um, and with that said, this is why I did the Riemann sum as a box, because out of everything, I think a box is the most useful type of Riemann sum, in my opinion. It helps in the box making process, right? If you're making a box, it's the best thing. Um, so Riemann sum, we have a four corners, right? So we can make four different types: a left bottom, right right top. That was supposed to be right top. Um, these are the numbers you need to put in later on. I didn't really, I messed it up. And then you plug into all of these, and then you plug into this big equation. I did dot dot top because I'm not going to plug all this in, and get 121.9 for this particular function. If you do it analytically, you get 121, and I just did it. I got it with the graphic calculator, aka Desmos, to get it, and it's similar to this, right? It's pretty similar. Although some of the other calculation, like the right top one, gets a big one because of how this is over here. Which the graph doesn't really justify how tall that is over here because it's like angled weirdly over here. I should probably get a better angle for that one. I don't know why it turned out well, right? Yeah, actually, I do know. I think I changed the function from this over here to over here. I probably would have fixed that. Anyway, you kind of understand that there's four corners. So if you do it for each corner, you can get four different numbers, and then you can add them all up and divide by 4. I did not do that because that's a pain in the ass, and I'd rather use what was it again? I'd rather use MATLAB to do that and just get it. I am not doing that by hand. That would be a pain in the ass. And especially since I don't think I ever learned this in school. This I learned the 1D Riemann sum in somewhere in AB or something, I don't remember, but I haven't learned the 2D. I've been told this, but I haven't you done it in class. So you know, it must be painful for a reason, and it is painful. I see why they would just skip, uh, because it's kind of the same concept as 1D anyway. So who cares? Anyway, now we go to Jacobian a little bit. I guess I could talk more about this, but I don't think we have to. And then we go to line and surface curl, which I'm starting off here. But yeah, that's the general idea. That also reminds me that these are all the ways to get a conservative one, which is used in physics 2A and 4A. Which I'm going to change. As you know, as we get through this and I actually make it properly, I delete this over here and keep it like mechanics, and also delete all these AP shenanigans and get rid of it. I only keep it there because it's clearly half baked. Because I think in usually this is always true. Over here, you kind of see how it doesn't. Over here, I believe. Where is it? After this, we have something here. I don't know where when it breaks, but I have a spot where it doesn't make sense for it to be there. I think it's over here somewhere. Yeah, you can kind of see that there's something's missing. Actually, I think I'm done with this. Oh shenanigans! Oh shenanigans! Oh shenanigans! Um, I did not know that. Because no, all the highlights. That's the reason why I haven't done it. And look at all the text boxes. Is clearly not done. That's why. Of course, I realize why. Okay, so but it's still good enough for me to say mechanics, I guess, and say uh, physics, mechanics, um, because I still want to get rid of all the boxes, um, which is gonna be a pain. Actually, maybe not. Why don't you? Why don't I do it right now while I'm here? First of all, sig figs. Well, I mean, they're not big problems. I just do 0 over here, and it should be good. And we delete highlight, not why. I forgot I had this thing over here. Let me delete that. Um, Clearly obvious. I need to highlight none over here and none over here. Yeah, I'm taking a break from math. Yay! Not really, because I'm only moving things around. It's not really that big of a thing I'm doing. Oh. Maybe I should change this. I don't like how I did this. I'm probably gonna make a new graph of this and make it better. Probably. Because I don't like how once again blocky these diagrams are. Probably going to do Desmos and just change it all up. Probably easiest way to fix everything. Oh, I used to like Jamboard where they had those grid system where it makes it easier. But let me just delete this first. Then what will happen? I mean that's where it's supposed to be. Oh my god, I'm such a okay. I think I do deserve to rechange everything because I'm looking at this and it's not good. Oh yeah, I am definitely not done with this. It's not to my specs, I guess, because it's not as good as I thought it was. Um, SI units are good, but it's kind of whack-a-mole where everything is. Thought it was more. Yeah, maybe I should probably put my classes back down there, to say I'm not really done with it. Um, yeah, put it back in there. It's not done. Clearly not done. And this is clear. This is clearly not done. This was like the beginning stage where I had two columns for some reason. It was a pain in the ass to fix it. But in all honesty, the only new thing I learned in Math 18 or linear algebra was the changing of planes. Oh, That pretty much explains Jacobian matrix. I just realized, because if in the linear algebra I learned how you could change over here to over here, and we figured it out. It kind of makes sense with that because it was a change over here with the number. Still doesn't explain everything, but it does explain the change of concurrent like this. So we could actually argue that with the determinant, maybe it'll work. Not sure, but it could work. No, it wouldn't work. I'm wrong. I'm horribly wrong. And then I can delete the Hessians just because I already learned it in vector cal, so this could be deleted. There's a lot of things here in Math 18 that is completely, except for eigenvalues. Yeah, eigenvalues is another big thing, but that's it in Math 18. Everything else was already learned in trig or calculus, so everything else can be deleted, which is lovely. I already moved it all up to other sections, so lovely. And as you can see, this is the old me. Nowadays I use overleaf, so it's clear. I probably need to delete all that then. Um, yeah. Anyway, what was I gonna do anyways? I don't. Huh. So I used to be able to do this. This was through MATLAB, right? So I just have to go to MATLAB and try to figure out how to do this again. Hmm. Because this is supposed to be part of the line integral, so I'm doing it wrong section. I don't know what the shit I did, but this was when I was like young, so it makes sense why it's here. I'm still young, but at least I'm not this bad. I did boxes on boxes of everything. Thought it was a good way to actually consider space. Now realizing it's complete horseshit. Bye bye.